today we're going to be talking about lesson 8.3, which deals with random samples and misleading statistics. So to start off, I want to talk about what it means when we use random samples, okay? When you use random samples, we do this when we want to survey a population, but we can't give that survey to everyone in the population. We want to pick a small group out of that population. Okay, and there's a couple of things that you need to do to make sure that it's fair and unbiased. So the first thing that we look for is that you randomly selected your group. Okay, you can't just pick any group that you want. It has to be random. Okay, one way to make a random selection would be to put all the names in a hat and then randomly pick them out. Okay? The next thing that we look for is that everyone in the population must have a chance to get picked. Okay? So when you put everyone's name in the hat, everybody has the possibility of getting picked. You can't just go into one class and say, I only want to pick a couple of kids from this table, okay? Because then everybody didn't have the chance to get picked. You need to make sure that everyone had the chance to get picked. And then finally, you want to make sure that your sample represents the population. So for that, you want to think about, are you picking people in the population that you're targeting? So let's say you want to survey your school, but you can't give the survey to everyone in your school. Then you don't want to go to the mall and start selecting people to survey there, because those people might not go to your school. Okay, you want to make sure that you're surveying people that are similar to the whole school. So you want to make sure that your sample has some boys, some girls. You'd want to make sure that you had some sixth graders, seventh graders, eighth graders. But you have to make sure that your sample represents that population. So we gave you a checklist, and you'll find that checklist inside your additional resources posted on the Google Classroom. So I highly recommend that you take a look at this checklist. I have it for you right here. And in order for you to say that your sample is unbiased, you need to make sure that you can check yes to every single one of these criteria. If for some reason you check no in any of the boxes at all, that means that your sample is biased. It is not a valid sample. Okay? So the first thing that we look for, does everyone in the population have an equal opportunity to be selected? Okay? So again, everybody must have a chance to get picked. So that's yes. Is everyone selected a part of the population? So again, if you're surveying your school, it doesn't make sense to go pick somebody in from the mall, because they might not go to your school. As long as everybody in the sample is part of the population, then that's okay. Does the sample have similar characteristics to the population? So again, are you surveying boys and girls? You're not excluding anybody that would be in that population normally. Okay, and then finally, does the sample represent the entire population, not one specific group? So again, similar type question as the previous one. Does your sample include the boys, the girls, the same race? We want to make sure that you did not target one specific group, that everybody who's in the whole population is also in your sample. Okay, so I'm going to look at an example. Here it says a seventh grade principal wants to plan a trip for all of the seventh grade classes. She wants to determine the favorite place to visit among the seventh grade students. Which sample would be the most appropriate for this survey? Okay, so the first thing that we know is that she wants to survey all of the seventh grade classes. So our population is the seventh grade classes. Population is seventh grade classes. Okay, it's very important now that her survey represents all of the 7th grade classes. Okay. So let's look at the first one. A, all of the girls in one 7th grade class. So that's wrong for 2 reasons. One, you only selected girls, so you excluded all of the boys in the school, and you only surveyed one 7th grade class, so not everybody had a chance to get picked. So A would be wrong. Okay, then we have B, every 10th student in the middle school. Okay, well, every 10th student is random, but we don't really care about all of the students in the middle school. Okay, we only care about the 7th grade classes. So B is incorrect. Then C, 1 out of 7 students at the basketball game. Okay, 1 out of 7 is random. We didn't have a targeted group there, but the basketball game is the problem. Okay, if you only survey people that went to the basketball game, you did not include everyone in the 7th grade. They did not have a chance to get picked. Okay, so C would be incorrect because you're targeting people. And then D, every 5th student in the 7th grade. So the every 5th student is random. And then it says in the 7th grade. So that's all 7th graders. So D is going to be your unbiased sample. That one would work. Okay. The second thing that this lesson talked about was misleading graphs. Okay. And you want to be careful when people present information to you. They can present it in a way that they mislead you. So there's a couple of things that we ask that you look out for. So the first thing we look out for is the information presented correctly? Okay, we want to make sure that the graph has everything that it's supposed to have. So one example, does the vertical axis begin at 0? This is a big one that we see, that they don't start it at 0. And I'm going to show you an example of why that could be misleading. Okay, another thing to look out for is, does the vertical axis use a consistent scale with no break? Okay, so sometimes when you see graphs, you might see that they're going up like this, 0, and they'll say 1, and then they'll say 2, and then they'll put like a little squiggly line, and then they'll say 100. Okay, that would not be a consistent scale. Okay, that has a break. It's going from 0, 1, 2 to 100. Okay, so when you present graphs looking like that, it's going to be misleading. Also, are the intervals equal for both axes? Okay, so again, did you count up by a consistent scale? Did you space it the same? Okay, so you can't skip 1 box, skip 2 boxes, skip 3 boxes. Everything has to be equal. Are the bars of the lines the same width and distance apart? Okay, and then finally, in 2 graphs comparing the same kind of data, is the scale the same? Okay, so I talked a lot about that. We're going to look at an example. It says, why is the following graph misleading? Okay, so here, there's a couple of things that you should look out for. The first thing that I noticed right off the bat, the title, massive increase in temperature. Okay, now this title is telling you what to think. They're telling you that there was a massive increase. Okay, when you want to make a fair, unbiased graph, you want to come up with a title that does not tell the reader what to think. Okay, so that's the first reason why this graph might be misleading. Another thing to look out for is it did not start at 0. Okay, here you notice it's going by ones, right? It was 81 to 82, 82 to 83, 83 to 84, 84 to 85. So they jumped from 0 to 81. That is not acceptable. Okay, that is why this graph is misleading. It makes it look like there was a massive increase in temperature. Now I'm going to show you what the graph should look like. Okay, this has the same exact data that the first graph had, but now you'll notice that it starts at 0 and it's counting by a regular interval of 20. Okay, so it's going from 0 to 20 to 40 to 60 to 80 to 100. Now when you look at this graph, even though it has the same data, it doesn't have a big change. You should notice that there's very little change. Okay, it looks very different than here, where it looks like it almost more than doubled from 2007 to 2008. But here it just looks like it went up by a little bit. Okay, so that's what we mean when we say that a graph can mislead you. Okay, they want you to believe that there was a huge increase, so they presented it like this. Okay, but here when we have a graph that is not misleading, you really get the whole picture. And another thing you should notice is the title. Now it says change in temperature. So yes, there was a change in temperature. It's not telling me to think that there was this huge increase. All right, so that's going to be it for today. Please try the Edulastic assignment, and if you have any issues, check out the additional resources or sign up for the Google Classroom Meet session. All right, have a good day, guys. Bye.